Have you come across a situation wherein you have current in some part of the house but not in the other part? Sometimes your house does not have current while your neighbor has. Have you come across this situation? Half of the houses, there's no light. Any idea? So this whatever the issue over here is, it's called as overloading, right? Have you heard of people telling go check the main box? There might be some tripping. Have you heard of this phrase? If not, just ask your parents what is this tripping and what is this main board. I'm sure any elders in the house, they can help you guys out. They would have come across this situation for sure. So overloading is the cause. It's the name given to this. It's a situation wherein the current in the circuit abruptly increases. So there is sudden increase in current beyond a point which the circuit can safely handle. So there's a certain limit the circuit can handle. Beyond that point, you can't handle the current and something happens. Basically, you can come across fire, your devices can get damaged. All of this is possible because of overloading. Okay, it's a serious issue. It's not a small issue. So yeah, the problem is pretty huge and pretty common as well. So the causes are quite a few. I've listed three of them. The first one is overloading can occur when the live wire and the neutral wire comes in direct contact. This is called as short circuiting. So basically, you have this live wire and neutral wire, right? These are generally connected to a device and that's how the circuit is completed. But by chance, you know, if this happens, that is, it will bypass your devices, live wire being connected directly to the neutral wire. The cause can be faulty wiring or old wiring or insects biting the insulation off. All of this can happen. So when this happens, what happens? Overloading happens. So there is sudden increase in current. Why? High voltage with no resistance. What happens? We have seen this. You know the idea of voltage, you know the idea of current, and you know the idea of resistance. Simple Ohm's law. Right? So there is sudden increase in current, and again, all of this can lead to your wires melting, fire, devices getting damaged. All of this is possible. So second causes overloading can occur due to accidental hike in supply voltage. Maybe some issue is there in your electrical supply outside your house, basically. Lightning and thunder, okay, high winds. All of this can cause overloading. Sometimes overloading is caused by connecting too many appliances to a single socket. If you have an adapter being connected to another adapter and so on and so forth, right? And you have connected big devices, right, which draws a lot of current. So this also can lead to overloading. So one of the advice is not to connect too many things in the same socket. So this also is a cause of overloading. Okay, so I have come across situation wherein I pretty much come across not this one. I've come across this, too many appliances, not this as well. Accidental hike in supply, yes. Once there was lightning and it actually struck, I guess, somewhere along the line, it struck a internet wire, and that fried my adapter. Not adapter, sorry. That fried my Wi-Fi adapter. I don't know. It's not called as adapter actually. Wi-Fi device basically. So that kind of literally got fried, and I had to get it changed. There was a small spark when that happened. So the room was dark. I was about to sleep, or actually I slept. Actually, there was a sound and there was a spark. I thought I just there's something, but when I got up, I tried to switch on, and system got switched on, but it didn't connect to the internet. So the cause was this, sudden increase in supply of voltage, not with my regular supply of electrical box and all of this, but because of wirings outside. Weird, but yes, this also can happen. Any kind of conducting material exposed to lightning, obviously it will the lightning will go through that, and any device connected to that will get fried. As simple as that. And yes, oh yeah, one of my student, they came across, I think, voltage supply due to fluctuation in voltage supply due to the electrical board. So their TV, their laptop got fried. This happened recently. So yes, all of this is possible. So loading can happen, and the solution is very important. So we are discussing the solution. Yes, I kind of discussed a lot about the problem itself, but the solution is this. We have something called as surge protector. Again, you can go and have a look. Example of surge protector is your tripping devices. So just go to the main board. If you are not sure of yourself, right, just ask someone to show it to you. So you can have a look, you guys can have a look at this. Then you have circuit breakers. Again, all of this is the same thing, just different names. So under this you have fuse. Okay, so one of the things which we have to discuss over here is fuse. So I have written over here, right? Fuse. So let's see what is this fuse and how will it help with our overloading. So fuse is a circuit breaker which prevents damage to the appliances in the circuit due to the overloading. So obviously it is something which breaks the circuit. See, overloading happens within fraction of second, and within that fraction of second, if you are able to switch off, or if you have a mechanism wherein it itself will switch off, right, that will protect your devices. So fuse is one of that. So this is, I have two fuses over here. This is around 2 centimeter. This is around 3 centimeter. This will allow a current of 5 ampere. Beyond that, what will happen? It will basically melt and it will make the circuit an open circuit. I'll explain that. This is for 10 ampere. So this is my, what is this? Stabilizer. So this is where you actually, if I open this, the fuse will be inside this. Okay, this is an extra fuse. But by chance, if something get fried, I can replace it immediately. So that's why they taped it. This comes along with the package. So this is your 5 amp fuse. So basically, the basic idea of fuse is this. It is always in series with this device. So you remember advantage and disadvantage of series. In series connection, if one of the devices get switched off, the entire thing gets switched off. So if I happen to switch on this and said there is a sudden increase in current, okay, which is beyond the operating current or voltage of this particular fuse, this will get this will melt off. This will get melted. And if this gets melted, what happens? It's like an open switch. It's similar to open switch. So there's no flow of current and your device will be safe. Okay, this is the basic idea of a fuse. It's as simple as that. So your tripping device, what instead of melting down, it will just switch off. How a tripper works, it's not that complicated. It is to do with heating properties and all of that. You have come across this in where in one of the heating device topic, like a geyser, how a geyser gets switched off, how iron box gets switched off. It works on the same principle, the tripper as well. Okay, so all of this has the same principle, just that a fuse will melt off. That's it. So yes, we came across a problem overloading, and the solution is your fuse that we are studying. Of course, there are quite a few solutions. And fuse is a small device that is connected in series with your, big devices. So fuse will melt off if there is a current surge which is behind a certain point. Of course, if it's below this 5 amp, this will not melt. If below anything below 10 amp, this will not melt. So depending on situation, you guys have to connect the devices, fuse. You can't expect fuse to work all the time. Looking at the situation, you have to put in the right fuse. Okay. So there are different fuses. What I've shown is just two very common fuse. There are fuses which are pretty big and used not in your house, even outside industrial places and even in your distribution boxes. Okay. So all of this is something you guys can ask someone to show it to you guys. Please don't try to do it yourself until unless you have someone to guide, right? So all of this you guys have to note down. This is part of your understanding and syllabus as well.